This is section 7.4. Today we're going to talk about factoring and GCF. So factoring is the mathematical task of breaking down an expression into its pieces, its factors and multipliers, kind of like I said before, working backwards. So the greatest common factor is the largest number that goes into all of the terms being considered. So let's look at some examples. So find the GCF of each pair of monomials. I'm going to teach you two separate ways to do this. The first way is you can make a list of all of the factors in each term. So let's list the factors of 24JK. We're doing number one. Okay, so the factors, you can start with the factor rainbow. 1 goes in there, 2 goes in, 3, 4, 4 and 6, 3 and 8, 2 and 12, 1 and 24, and then a J and a K. Those are all factors. Okay, now we're going to do the factors of 32J. List them right underneath. So 1 is a factor, 2 is a factor, 4, that pairs up with 8, 2 pairs up with 16, and 32, and we have a J. So now if you circle all that you have in common, let's see, we have a 2 in common, we have a 4 in common, 8 is the highest one, and then a single J. So our greatest common factor is 8J. There's also another way, it's the step method. Make a step like this. Okay, you put your two numbers or however many numbers that you are trying to find the greatest common factor inside like that. So you start out by pulling out a multiple. So let's say 4J. We know they both have a J. So 24JK divided by 4J is 6K. 32 divided by J is 8, just 8. Okay, so there are still common factors here between these two, so we're going to make another step. So 2 goes into both. So 2 or 6K divided by 2 is 3K. 8 divided by 2 is 4. We're going to look at those. There's still nothing that goes into both of them. So now we're going to take the two side numbers and multiply them together, and look, we end up with the 8J again. So the greatest common factor of 24JK and 32J is 8J. Okay, so let's do the stairs for this next one. 10x cubed and 25xy squared. I'm going to try 5 seems to go into both of them, and 1x. So 10x cubed divided by 5x is 2x squared. 25 divided by 5x is 5y squared. Nothing more. There's nothing in common more. So my greatest common factor is 5x. All right. Let's look at number 3. So I have 14x to the 5th, y to the 9th is one of the terms, and then 17, 17x cubed, y to the 17th. Okay, so there is no factor that will go into both of the coefficients, so they're going to have to you're going to have to ignore those. But there are common exponents. So what's the highest exponent of x that will go into both? Well, 3. So x cubed. The highest exponent of y that will go into them, that will fit in, is the 9th. So when you divide, you have 14x squared here and 17 y, 17 minus 9 is 8, y to the 8th. So my greatest common factor is x cubed y to the 9th. Okay, so the next part, you are supposed to factor out the greatest common factor from each polynomial. So for number 1, it's a binomial. You are undistributing. So let's find the greatest common factor. So you can do this until you can see it without doing this. So a 4 goes into both of these, right? And 1t. So 48 divided by 4t is 12t. 48t squared divided by 4t is 12t. Negative 12t divided by 4t is negative 3. There's still another factor. 3 goes into both of these. So 3 goes into 12t 4t times and into negative 3, negative 1 times. So our greatest common factor here, you're going to multiply that, is 12t. So that's on the outside. So if we divide 48t squared by 12t, you end up with 4t, and 12t divided by 12t is negative 12t divided by 12t is negative 1. So you are going to pull out whatever they have in common. And eventually you can leave this whole step away if you can see it. So if you look at number 2, what do all of these have in common? You cannot pull out 5 because 5 does not go into negative 9. If you look at the x's, the variables, the highest that you can possibly put into all of them is 1. So I'm going to put x on the outside. 5x squared divided by x is 5x. Negative 9x divided by x is negative 9. 15x cubed divided by x is 15x squared. So if you remultiply this, you should end up with where you started. So it's going backwards from multiplication. Number 3. So let's factor what's common here. So you can't pull anything out of all of them. There's nothing in common because this one doesn't have an x. 5 doesn't go into 12 or 3. So you can have expressions that are prime. They're factored fully at this point, or as far as we can right now. Prime. All right, number 4. 6x squared y minus 9xy plus 3y squared x. Well, obviously we have a 3 that we can pull out of all of them. All of them have an x. The highest power that you can pull out of all of them is 1. Not all of them have they all have a y. The highest power you can pull out is 1. So 6x squared divided by y is 2x. Negative 9xy divided by 3xy is negative 3. This is a negative. And then 3y squared x, which is weird because they usually should be in alphabetical order, would leave 1y, or just y. Let me rewrite this better. 3xy, quantity 2x minus 3 plus y. All right, that's it. This is something you got to practice.